Welcome. In this video, we're going to create a Visual Basic application that integrates an AI system that we'll create. And it is a tutorial step-by-step process, so you can stop and start the video and do this yourself. We are using Visual Studio to do the Visual Basic application. But the first thing we'll do is use AI Builder 2 to create and export an AI system. It'll be a very simple system. We're going to keep it simple to really focus and illustrate the process for integration. We're then going to create a simple single form-based Visual Basic application. We're going to copy 3 necessary files to the Visual Basic project directory. We'll need the runtime DLL, we'll need the exported AI system file, and we also needed the conveniently created manifest file that AI Builder 2 writes for you when you create this exported AI system. And you'll see where that comes in handy when we need to get at the IDs for the inputs and the outputs. We're then going to go to the AI Builder website to copy API declarations from the online help system. They're just straightforward and easy copy-paste API declarations you can drop right into your form or module in Visual Basic. Because as in Visual Basic and not in C and C++, we don't use a header file. So we've done that for you ahead of time. And then we're going to write the code to load the system, set the input values, compute the AI system, and get the resulting output values. So let's get started. Alright, so here we are in the AI Builder IDE. We're going to add a system module. We're going to add 2 inputs and 2 outputs. We're going to connect these 2 inputs, and we're going to connect the single system module to the 2 outputs. Inside that system module, we're going to add an addition component and a multiplication component. Remember, we're keeping this very simple just to illustrate the process of creating an AI system, exporting that AI system, and integrating that AI system into an application. And in this case, we're going to use Visual Basic. So we just connect these 2 inputs. We're going to add them. We're also going to multiply them. And we're going to take these 2 results, the addition result and the multiplication result, send them to the output layer of the system module, which is already connected to output 1 and output 2. We are then going to select export runtime system. And again, if you've purchased the license to the AI Builder runtime, you will be allowed to continue this process. Otherwise, you'll be shown a dialog that shows you how to purchase. But in this case, we're just going to simply export a runtime system. We're going to call it test.t2r. We're going to save that. Now you'll also notice that once you've saved a runtime system, the successful runtime export dialog comes up explaining that you've been successful, and it tells you that there's a manifest file available. It gives you the name of the runtime file and the name of the manifest file, and it will prepend AIB2 runtime or RT manifest underscore test.txt. And the current project, we didn't save the name of the project yet, so it's going to show us untitled. But we can also view that manifest. It's just going to launch the text editor, and it's going to give us what's in that manifest. And this is really key because we're going to be using this. What it does, it gives you the name of the file, the name of the original of the runtime file, the exported runtime file. And it gives you other information about your project. It tells you the number of system inputs, their name, their ID. I get a little misalignment in the table here, and the description, and we didn't provide a description for each of those inputs. And also the output 1 with an ID, and it's a non-array output. If it was an array output, it would say that, and it would also tell you how many elements it holds. And output 2 with an ID, and it's also non-array. And we'll use these in our integration app or our host application to gain access to these inputs and these outputs, because we'll need to set the values of the inputs and we'll need to retrieve the values of the outputs. I'm going to pause here. Okay, now we're in Visual Basic. We're running actually Microsoft Visual Studio, and we're going to create a Visual Basic application. So we'll select File, New, Project, Windows Forms Application. And let's name this Host Test, and choose OK. Starts us off with a simple form, and which has code behind it, and we'll get there in just a second. Okay, and before we go any further, one of the first things you're going to want to do, we want to make sure that the runtime library, that's the DLL for the AIB2 runtime, the manifest file and the original exported runtime file are in the right directory. So our application is called host test, and if we go down to our local directory here, this is where we're at. It's projects host test. In the project directory for Visual Basic at least, double click on host test and then click on bin and then debug, and that's where the executable will be placed and run from when you're in run mode. And I've put the AIB2 runtime.dll file here. You just copy and paste from your local directory in the AIB2 application. And I put our test.t2r exported runtime file here, and that is what holds the AI system we exported. And here is that manifest text file that includes the IDs of the inputs and outputs, and we're going to be using that shortly. But we can close that now. And if we go back over to one of the things we're going to want to do is double click on this form, and before we go much further, let's just copy and paste some code from the AI Builder Help and Support website, and you can get there by clicking on within the AI Builder application online help system. And if you click here, you're going to load this page here. Let's see if I can minimize that. It's AI Builder AIB2 Help default.php, but that'll automatically come up for you. And if you go to the Runtime API reference, this is really where you're going to get the information you need on each of the API calls. And although it's very simple to operate an AI system, it's good to have a detailed reference. So I've just clicked on that. That's the API reference. And this shows the calls that need to be made to operate that AI system. And keep in mind, you're just simply loading the file, setting the values, performing a cycle of execution, retrieving the result, and then when ready, unloading that AI system file. And in fact, this can be done for you automatically. But right down here at the more towards the bottom of the AIB2 API page is the Visual Basic API declarations, and this is just a convenient thing. You can just copy this, do a right click and copy, and then go back to that form module. Remember, we were here. We're going to double click that, and just anywhere in here actually I can do a paste, and those are all the declarations for you, nice and convenient, that are compatible. And remember though, you want to make sure that in your bin slash debug directory where your executable will be, you want to make sure you have the runtime DLL there and the AI system file as well. Alright, so now that we've done that, what we're going to do is go back to form mode, and let's add some controls. We'll have a couple of text boxes. Let's see. And these will be for the values, and let's see if we can line those up. And we'll have the output values over here, 1 and 2. And let's put some labels to those. And I'm going to pause the video here so I can do this much faster. Okay, we're back, and I've just placed 4 labels here. If you recall our AI system, if I can pull that back up real quickly, it has 2 inputs and it has 2 outputs, and we have a system module that just simply adds the 2 and also multiplies the 2, giving us both results. So I'm going to minimize this, and so we have reflected that here. What we can also do is let's go into this form module. And on the load event, one of the things we might want to do is just get the version. So let's declare a variable. We'll say d version as string. Actually, it's as a double because that's the result. And what we want to do is find out the version of the library that we currently have. And we will, let's see, we'll just say d version equals, that's the result of this call, tmai system get version, and close parentheses, and let's go back to our form, and let's add a text box, another one. Let's see if we can get back here, and this will be the name of the version, and let's give that a label as well. Oops, not there, but there, and that will be version number. Okay, runtime. And this is just to illustrate a point. We're going to want to give this a name. Let's call this text box version, and we'll save that. So now we just have a label and a new text box. And all we're going to do is put in that text box the .text equals d version, and that's .toString, I think it is, in Visual Basic. Okay, and that should do it for that. Let's run this. Okay, so we have a version number, and we know that the runtime library is listening to us, and it's right here in the executable directory, and we've got the update here. I'm going to pause, and we'll get back into the rest of the coding. Okay, the next thing that we're going to want to do is actually, now that we know that the runtime is available and we're accessing it, we want to load our exported AI system runtime file. And you recall that we named it test.t2r, and that's Tinman 2 runtime, the acronym on the extension. And so we do a couple things. One, we're going to be using this function here, tmai system load, and it looks like it takes the file name, it takes the ID of the AI system, and a sysfeedback structure, and that structure is conveniently declared for us as well up here. So let's just dimension a new variable, declare a new variable. We'll just call it sysfeedback as sysfeedback, and then what we're going to want to do is dimension a new variable to capture the result of the call, and that's if we look at this function call tmai system load, it returns an integer. That integer is meaningful for us because we want to know if it was successful. If we get a 1 back, it was successful. Anything else, and it wasn't. So what we're going to do is we're going to say I result equals, let's go up and copy this, tmai system load, and we're going to give it the name. Let's just name it here. I think we'll be okay. We may have to declare a variable first. Let's see, test.t2r, and always put 0 for the ID of the AI system. That'll be changed once we allow multiple AI systems loaded per API. Let's see, and then we want to give that sysfeedback structure. So that's that. And so the result, if the result is equal to 1, then we are good. Else we are not loaded. And we can do something relative to that. But let's just see what we have right now. We're getting a little feedback already from the Visual Studio saying that you haven't cleaned out some of these variables prior to their use. Let's see if we can get away with using it. So we've got everything we need. We're just going to load. This is the form load event. So as soon as this runs, we're going to get the version and we're going to get the file. Let's run it. Okay. You see that the Visual Studio Debugging Assistant, this is the Managed Debugging Assistant, has noticed a pinvoke stack imbalance. Anytime you run on a 64-bit system and you have a C declare external DLL, you're going to get some stack imbalance messaging back from the managed debugger assistant. So what we need to do is let's turn that off. That doesn't mean there's an error in the DLL. It just means that there's a managed to unmanaged and it's 32 to 64-bit check imbalance. So let's go to debug exceptions. And let's go to Managed Debugging Assistance. That's your MDA assistant. And we're going to go down to pinvoke stack imbalance, and we're going to not throw that error. There shouldn't be any harm in that. Let's run our application. And now we're running again. Okay, so, but we're not getting any feedback that we're good. We don't know that. So we're going to close this down. And what I'm going to do is I'm going to take this text box that we created for the version, and what we're going to do is we're going to add to it plus success. And hopefully if we see that we're loaded. This is very simple feedback mechanism here. So we'll just launch again, and bingo, okay, we have success. So the file is in fact loaded. All right, now what we want to do, we want to populate these two values and we want to execute and see the result, which is pretty straightforward. Let's see, what we want to do first is let's add a button, and that button is what we're going to use to actually compute the AI system. Let's change the name of this to execute. All right, and let's double click this to go into its click event subroutine. And what we're going to do here is do three things. The first thing is set the values of the inputs. The second thing we're going to do is we're going to compute the result. And the third thing we're going to do is to retrieve the values of the outputs and present them. I think we've got a retrieve spelled there. I think it might be an IE actually. And so those are the three things we're going to do here. Now this is where the manifest file comes in handy. And so let's load that back up. Let's see if we can get that loaded here. Go into our directory. Remember, we placed this at the very start in our bin directory conveniently so we'd have access to it. And remember, you need three things here: the DLL, your AI system exported file, and here's the manifest file. So if I double click on the manifest file, here are those IDs that I need and the output IDs. I'm just going to simply copy this. Let's see, just copy the whole thing here, and we'll place this right over here, but we're going to do it, let's do it right here, and let's just comment all of this out so it doesn't screw us up. Okay, so let's set the value of these. Let's going to dimension a couple of variables. ID input 1 as integer, dim ID input 2 as integer, dim ID output 1 as integer, and dim ID output. And you can fast forward this part if you'd like. I just want to continue forward because it is pretty easy. It's just tedious. And you're going to do this only one time. These, you're probably going to want to save these once you set them in a global variable so that if you have repeated events in computation, you can just pull that global variable up. Okay, so let's set these. The ID input 1 equals, and that equals 25879. And ID input 2 equals, and that's 18720, and that's that here. And the next thing, let's see if we can do the same thing for let's just copy these to speed this up, and we'll say ID, this is ID input output 2, and let's copy these as well. Okay, so now we have our IDs set, and so the what we want to do before we can compute the result is actually set these values. But we want to set these values by whatever's in these text boxes. And so this is text box, let's see, this is text box 1, and this is text box 2. So let's just work with those two guys right there. So the value, we're going to need another variable. I value 1 equals dim as integer, and dim I value 2 as integer. And actually, this needs to be a double, and this needs to be a double. And we're going to change those to D. I like to prefix the variable names with the type of data that it is. It's convenient when you access that in later coding. So now what we want to do is extract. So we say D value 1 equals text box 1 dot text, I think we can get away with that in Visual Basic. You certainly can't in C and C++. You'd have to do a string to floating point conversion. But we're going to just take advantage of this. dvalue2 equals text box 2 dot text. And so this is assuming that we actually put text into those boxes. And then we're going to compute we need to set those values. So this is where we use set value, TMAI system set value. And we'll need the ID of the input and the value, and that's that. So the first step is to call that function, excuse me, and we need the ID of input 1 and the value of 1. Let's do the same thing for the second one, ID input 2, D value 2. Alright, so we've set those. Now we want to compute. This is the easiest step of all. We just choose TMAI system execute, and we just need to specify the ID of the system, which is always 0 again. So we do this. Whoops, I copied the whole thing. Undo that. Let's go up, execute, copy, and we'll specify 0. And now we retrieve the value of the outputs. And that is, we just want to use this one, TMAI system get system output value. And that simply takes the ID of the system, which is 0, the ID of the output, which we know, and by reference, a double value that we would have declared already. So let's go here, call get system output value, 0 for the system, ID output 1, and comma, and we're going to need to declare a variable. And so we need to back up, let's see, dValue result 1. So we want to dimension dValue result 1 as double, and we want to dimension dValue result 2 as double. And let's do the same thing here. Copy, paste. Oh, we got an extension on that one. And let's see if we can an ID output 2 and result 2. And then simply we want to set those text boxes. And so let's see what the names of these are. This is text box 3 and text box 4. So now we want text box 3 dot text equals d value result 1. And I think we need to do toString here. Let's just do that to be safe. And let's just do a copy paste and change the digits on that one to speed it up. Text box 4 equals dValue result 2 dot toString. So that's really it. All right, we're setting the values of the inputs. We did a lot of declares here. We're simply declaring integers to hold the IDs and declaring doubles to hold the result. I think we've done it all. The APIs are pretty straightforward. Just setting the value, calling execute, and getting the output values and presenting them. So let's run the application. Okay, so we've got a successful load, we've got a successful version number. Let's say 3 and 4, and let's click execute. 3 plus 4 is 7, and 3 times 4 is 12, so that's correct. And let's just try 67, execute, and we get 3 plus 67 is 70, and 3 times 67 is 201. I'm going to stop here, and if you can just allow your imagination to run, you can have a very complicated or sophisticated neural network underneath that takes in values and symptoms and or conditions and computes a result without an execute button. It could also do this autonomously and continuously based on serial input. The key is that once that file is loaded, your system, your AI system, is operating underneath and ready to be computed. And these values can either be entered manually or via a database, or they can be taken from a serial port through, for say, a robotics input or a sensor, and then those all of that system computation is done instantly within milliseconds, producing the outputs, which then can be accessed by the host system to either simply display or to modify the effectors of the host environment. And I'll stop there. Thank you.